Hello, and welcome to Lesson 7 in our polar uh, equations unit. Today we're going to learn about complex numbers in polar form. Now, Demov is the person that introduced complex numbers to trigonometry, uh, and he has a property named after him. But first, let's start with the complex plane. Now, the complex plane, what we do is we put anything that's a real number on the x-axis, anything that's imaginary on an imaginary axis. So this point 3 plus 4i, we move 3 to the right and 4 in the imaginary direction. So our point would be right there. We can do operations on complex numbers, and we've done this before. If we're just adding two complex numbers, 2 plus 5 is 7, negative 3 plus 4 is 4i. When we're subtracting, now we distribute over the parentheses. So 4 minus a negative 8 is a 12. 5 minus an I is 4i. Now when we're multiplying complex numbers, you do FOIL. First, outsides, insides, last. The first would give us 10. The outsides would give us 14i. The insides would be negative 15i. And the last would be negative 21i squared. I squared is the same as negative 1. So this would be, this term we could also say would be plus 21. So plus 21 and a 10 make 31. If we combine the i's, we'll have minus 1i, or minus I. Now if we multiply these together, these are called conjugates because one is positive and one is negative. The first will be 4. The outsides will be 6i. The insides will be minus 6i. So those will just cancel out. And then the last one will be negative 9i squared. The I squared turns that to a positive. 4 plus 9 is 13. Alright, so now let's go back through some basic equations, but now keeping in mind that this is real and this is imaginary. We can find A by saying R times the cosine of theta, just like we did with our x's and y's. And now for a y or a b, it would be R sine theta. R squared is going to be a squared plus b squared. And if we wanted to find theta, we can just take the inverse tangent of b over a. Now we have certain names for these. The R is called the modulus or magnitude, and the theta we call the argument. Oh, and I forgot the most important part of this slide. The top is z equals cis theta. It's kind of, this is right here is a shorthand for that. So we're taking R times cosine plus I sine of some theta. So we expand this to be this. So let's transform 4 plus 2i into polar form. So let's look at this for a second. If I go 4 to the right and 2 up, we want to find this distance and that value there. So if I want to find the hypotenuse, I'll take 4 squared plus 2 squared equals c squared, or maybe more appropriately r squared. And so this would be 16 plus 4 equals r squared, or 20. Now when I take the square root of 20, that should be able to be broken down in square root of 4, square root of 5, which would be 2 root 5. Now if I want to find this theta, tangent of theta is going to be 2 over 4. So now I just take the inverse tangent of 2 over 4. That should be a 4 down there. And when we do that, all right, now I pause it to take out my calculator, get this loaded up. First, make sure your mode is in degree. And then we take the inverse tangent of 2 over 4 to get 26.565. So our theta is 26.565. So now let's look back at our polar form. It says our polar form is r CIS theta, or r cosine theta plus I sine theta. Let's take a look. We have our r now, and we have our theta. So our new form would be, we just plug in the r and the theta. So 2 root 5 cosine I sine 26.565. Because it's in that form. All right. Now, you guys try to transform negative 5 plus 7i. You can pause it to try it on your own. Now you go 5 to the left and 7 up. So negative 5 in the reals, 7 imaginary. 5 squared plus 7 squared equals c squared. 25 plus 49. That's going to be, what, 64? No, not 64. 74. My math isn't so good this morning. So now we square root both sides, so it'll be the square root of 74. Now I can't think of anything that goes perfectly into 74. I think that's as far down as we can take it. So now we need to find this angle. Now we're not just talking about this angle, we want that angle there. So we can do the inverse tangent of 7 over 5, or we could do negative 5. There's two different methods. If we do inverse tangent of 7 over 5, inverse tangent, 7 over 5, we'll get a positive value, which is 54.46. So that would be this one here. So if that is 54.46, we'd have to subtract 180 from that. So 180 minus that answer will give us 125.53. So let's say 125.54. It looked like the last number would round up. So now we have our angle, we have our r, so our value would be root 74 cosine I sine of 125.54. All right. Here's another problem for you to try. Negative 3 minus 5i. Go 3 to the left, 5 down. Our r value is going to be 3 squared plus 5 squared equals c squared, or 5 plus 29 plus 25, which is 34. And the square root of 34 cannot be broken down. And now we need to find this angle. I would take the inverse tangent of 3 over 5. So this is about 31 degrees, approximately. So it's 31 degrees past 180. So my theta is going to be 211, about. So this in polars is going to be root 34 cosine I sine 211. Let's throw a little degrees up there. All right, now if we're going to go in the opposite direction, we want to convert this back into Cartesian form, which is another way of saying rectangular. So we just expand this, and we actually write cosine 144 plus I sine of 144. Multiply 5 over the parentheses, so we have 5 cosine 144 plus 5I sine 144. And if I bring up my calculator, 5 cosine 144, 5 sine 144, those give me my two values. So this, my real part would be negative 4.04, I believe, for 5. Let's just put a 5 on there. And my I part would be 2.94 I. So for this, let's see if both of these make sense together. 5 144 is going to be 5 somewhere up in here. Maybe more like that. Now, in rectangular that we're saying we're moving to left about 4 and up about 3. Does that make sense? Yeah, 3, 4, 5 triangle. Yeah, that's reasonable. And we go to left 4 and up 3. Yeah, that seems to make sense. Try this one on your own. 3 cosine I sine 251. First thing we do is expand it. Now we multiply over the parentheses. And now we just do the calculator work. 3 cosine 251. I could even probably do second enter and just change that cosine. Oh, I did that. I didn't see that. I did 2,511. So let's do that again. And now just change this to a sine. And we have negative 0.977 and 2.837. 2.837. And I believe that was negative also. And if you think about 251, both the x and the y will be negative in that situation. Now let's try this without a calculator. So if I wanted to expand this, this would be 3 cosine 225 plus sine, or I should say I sine 225. Cosine of 225 is going to be right there, and that's a 45, 45, 90 with negative 1 root 2. So the cosine of 225 is going to be negative 1 over root 2, which, when I rationalize it, my phone's ringing. All right. Now, this would be negative root 2 over root 4, which is 2. That's a negative. And actually the sign would be the same thing because opposite over hypotenuse is the same thing as adjacent over hypotenuse. So this would be negative root 2 over 2 plus I negative. So since that's a negative, we can change that to a minus. And now when I multiply this 3 over the parentheses, I have negative 3 root 2 over 2 minus 3I root 2 over 2. All right. Now try this one. Pause the computer and try it on your own. 330 is down here. So that would be 4. That would leave a 30-degree angle there. So that would be 2 and 2 root 3. Or we can go back and say that this is 4 cosine 330 plus I sine 330. Cosine of 330 is going to be opposite over hypotenuse, which is 1 over 2. Cosine is going to be adjacent over hypotenuse. So that would be root 3 over 2, where the sine is going to be negative 1 over 2. And then we have an I along with that. So when I multiply over the parentheses, this is going to be 4 root 3 over 2 and minus 2I. And you'll notice that this is 2 root 3 minus 2I. And you saw that I did this first. I did that kind of as a mistake. I was going to show you along with this, but once I finish this. But there's 2 ways you can do the problem. See the connection? 4 CIS 330 means you go to the right 2 root 3 and down 2. And if you know this, your 30, 60, 90 triangles, you could just find them without going through all these steps. All right, now for I, some people get confused with this when you shouldn't be. 4I is just up this distance, 4. So we could go through the whole thing, or we could just see that since 4, we know 4 is the radius, we can say it's 4 cosine I sine. What degree is that? 90 degrees. All right, here's your homework for tonight.